Okay, everybody. Hope everybody's doing well. Welcome back to another lecture. Today we're going to talk about finding a resultant of concurrent forces. This is important because in many cases, if you're taking statics, this is like the first thing that you have to do for homework and for a quiz. And you have to understand how to take something like this here, which is the vector sum. Vector F1 plus vector F2 equals the resultant. So if you have a force like this and a force like this, F2, this is F1, then the vector sum of that is its resultant R. And that's how we're going to look at this today. We're going to look at a couple examples. First is the parallelogram law, or the triangle law, and I really like using this triangle law. It works very well. You see when you look at this that F1 plus F2 is equal to F2 plus F1, which is equal to R. R here is the resultant of two forces adding together. Now you got to remember that you take a force, and from tail to head, and then from here tail to head, this is your resultant here. Okay, I see a lot with students, especially having problems with that. So we've got to make sure that we put the forces correctly, so that you can come up with the resultant with the right sense. This trigonometric method using the law of sines is really helpful. When you understand this, eventually we'll get to the point where we're summing forces and force systems by utilizing components of those forces. But we look at this example right here of this system of two concurrent forces. Concurrent meaning they're going through one point. They're both going through this point right here. So there's no rotation. F1 is rotated gamma clockwise from the horizontal, and F2 is located an angle phi counterclockwise from the horizontal. So what we're really doing is that we're taking F2 plus F1, because it's just F1 is here, same thing, F1, and then that's the resultant right there. And that's what we have over here. So you see that F2 is shown as phi from the horizontal. F1 is gamma from the horizontal, but beta is equal to gamma plus phi. If this is phi, then when you look at the horizontal, right, then that's phi, and if that's phi, this is phi. So gamma plus phi right here is equal to beta. These are important points when you're looking at being able to solve your resultant of these two forces. So we get some other names. We call this angle between F2 and the resultant, we call that alpha. Just give it that name. And then we're calling this theta, which is the angle between the resultant force and F1. The reason we're giving these all names is because we're going to use the law of sines and the law of cosines to solve for this. So this is actually like R1, 2, because it's the resultant of vector 1 and vector 2. So check it out. We have these two right here are very important. It's what you're going to be probably utilize very early on in your course. So the law of sines is telling you that we're going to go over this now, all this. That F1 over the sine of the opposite angle, so the included angle opposite, so over the sine of alpha, is equal to r over the sine of beta, which is the opposite angle, which is equal to f2 over the sine of theta, which is the opposite angle from that. Okay, so that's just the kind of how the geometry is set up. And then the law of cosines states that if we have two forces and we use this equation, that f1 squared plus f2 squared minus 2 times f1 f2 cosine, it's not on the sheet, it's covered, it's cosine of beta right there, okay, cosine of beta. So when you're solving for these things, typically what we do is we'll know what f1 is and f2, or maybe we know an angle, but we'll have enough information that we can say, if we want to find the value of r, ultimately we're looking for that value of r right there, we'll start by saying, okay, if we have f1 and f2, and we have enough information to find this angle right here, beta, that's the one we're looking for. When you have that angle, you can use the law of cosines, because you'll know f1 and f2, and you can do minus 2 times f1, f2 cosine beta, and that is one way that you can solve for the resultant. Now, the way this is done is, in many cases, you'll have, based on the sense and the direction of these forces, so it kind of becomes a little bit of a puzzle as you're looking at the concurrent system. But you can start up here with the law of sines. And so listen to this very carefully. You find when you have a full quotient. So in other words, it might be fairly consistent that we can solve for that we can solve for f2 and the sine of theta, okay? Maybe based on what's given us, we can do that. Or in another case, we might actually have, we know what phi is here, okay? And we have enough information that we can solve for gamma. I'm sorry, in that case, that's alpha. That one's alpha. So what you do is you use your law of sines to come up with these angles. Typically, you can find, let's say we use the law of sines to determine what alpha is here, and now we know what it is here. And then we can solve for, once we have this quotient, then we can use, say here, if we know what f2 is, then we can solve for theta. And once we know what theta is, then we can solve for beta, because we know that alpha plus theta plus beta is equal to 180 degrees, so you solve for beta. Once you know what beta is, then you can come back down here and you can do a law of cosines and solve for r. So what I think we'll do is I want you to take some time really looking at this, the thought process behind what we're doing here. I think on my next lecture, I'll do a couple examples like this. But the key thing that we're trying to remember is whatever we have a force and another force, and if we know that they end up somehow going through the same point, if we know various angles that are involved with what we're doing, maybe from the whatever, if this is an F1 and this is an F2, then we can take F1 plus F2 and we can come up with a resultant 1, 2 and solve for it. So I'll give you some examples on my next lecture here, and we'll actually go through and we'll follow what we want to do in order to calculate R. Because once you have R, we're going to use that for a lot of design. Again, this is very important because it's going to be your resultant of two concurrent force system. Going through the same point, finding the resultant. And most likely, in any exam in statics, this would be your first quiz or your first exam to be able to do it. When I give this to students, I'll typically give them, they can either just solve it with the triangle law, or they can come down here and use the law of sines and law of cosines. Let them do it the best way they can of those two after we go through them, and it's either all or nothing. It seems like the students really get it exactly right, or they just really bomb this. So I want to take the time for you to look at these examples and be able to understand it going into an exam. So quickly, understand what's going on here. Understand that when you have your system, F1 and F2, you can form this triangle. You can go through the law of sines to come up with all your various angles, but this is the one you're looking for, beta, because that's what's going to go in down here in the cosine of beta in your law of sines, and then you can solve for r. That's what we're looking for, the result. So, like I said, look at it closely. Understand where this is coming from, and next time we'll do some examples. Okay, very good. All right, everybody.